There's a moment every skater knows. You're leaning into a curve, speed feels right, everything's quiet. But then the street changes. Maybe just that white line painted, or maybe a dump patch you didn't see before. And suddenly you're not thinking about speed anymore. You're thinking about whether your wheels are still on your side. That's grip. You don't notice when it's there, only when it starts to leave. I'm Daniel, we're out here storming the streets. I've been building and testing electric inline skates, storm tracers, for over a decade. And if suspension is how you survive impact, and wheel diameter is how you manage energy, grip is where control actually lives. This is where the street decides what you are allowed to do. But what actually is grip? Grip is friction. It's the force that wheel can push against the ground without slipping. Grip is what allows you to turn, accelerate, brake, everything. Loose grip and none of the rest matters, right? Loose grip doesn't matter your motor, doesn't matter your weight, doesn't matter how tall your ride is. If you lose grip, you lose everything. That's true for cars, bikes, normal skates, and especially storm tracers. Think about a race of speed inline skaters. At the very start, when they hear the shot, they don't just push harder, they load on top of the wheels. If there's not enough grip at that very moment, all that leg power turns into slip. Energy goes nowhere. On storm tracers, you also feel this instantly. You try to launch hard on a dump asphalt, motor engaged, torque hits, and the wheels spin. And you're not accelerating, you're just wasting energy. And it's not even a burnout, right? Grip is what turns power into motion. Without it, torque's just noise. Now, here's where storm tracers become different from normal inline skates. Normal skates brake by sliding their wheels, so loss of grip is expected. But storm tracers, they can brake electronically using the motors. That means braking only works if the wheel can still hold onto the ground. Picture this. You are on a downhill, holding speed comfortably, you're not panicking, just managing the run. Midway down, you run onto a darker dump patch of asphalt. It's still wet. You apply the brakes, but if your grip is too low because of the wet asphalt, you're actually going to stall your wheels and you're not going to brake. And you might actually lose control and crash. That's what happens when the wheel tries to slow down faster than the grip with the street allows. In the best case scenario, your wheel momentarily stalls, but you gain grip again once you go through the wet patch. And the worst case, of course, is you lose control, your wheels stall completely, and you go to the ground. But that's not rider error, that's traction limits. On storm tracers, grip isn't optional. It's what allows brakes to work safely. Besides how grippy the compound of the wheel actually is, you can have softer compounds that offers more grip. Besides that, you need to look at wheel profiles. Most inline skate wheels use a very narrow profile like a V-shaped one, like this. Some like a V-shape or a round-shaped profile. And that's very different, for example, from skateboards or quad skates, which usually use squared profile wheels. But why is that? The main reason is because inline skates, they lean, while skateboards and quad skates don't. They keep the whole wheels touching the ground at all times. And of course, streets aren't flat. When you think about that, on paper, a squared profiled wheel has a lot more contact area to the ground, so it theoretically would have more grip. But in reality, when you lean, if you have a squared wheel, you would actually turn the wheel and you would lose all the contact and we have only the corner of the wheel in contact to the ground. Also, when pavement is uneven, you have to climb through the imperfections and you lose that contact area anyway. And a rounded profile keeps consistent contact across lean angles and rough surface. And consistency beats maximum area, because it doesn't matter how much surface area you have when conditions are ideal if you don't know how much surface area of contact you will have when things go wrong. So here's something subtle but very important. A more V-shaped profile doesn't just reduce contact area, it also deflects obstacles, loose pebbles, grit, small debris. Instead of rolling over them, this kind of wheel tends to just push the obstacles aside. That means fewer sudden jolts, fewer grip spikes, and cleaner lines. Rounded profiles may grip better on clean pavement, but they're more likely to run over debris instead of pushing them aside. And again, trade-offs. Every time you make a choice, you gain something and you lose something. Now let's talk about a little bit more about compound. Skate wheels are made from polyurethane and their hardness is measured in a scale called short A. Most inline skate wheels nowadays use around 85A hardness. A lower number on that scale means a softer wheel. So a 80A wheel is softer and usually more grippier than a 90A wheel. When you have a softer wheel, you usually have more grip, more deformation, and more rolling resistance. And harder wheels, the opposite. You have less grip, less rolling resistance. This is where people often compare skates to car tires, and that's where it breaks down. Car tires are incredibly grippy and abrasion resistant, but they are way too soft and sticky for inline skating. If you put true car rubber on inline skate wheels, they would feel sluggish, heavy, and very hard to turn, because inline skates rely on controlled slip to turn. Too much grip and the skates feel locked, grounded. But that's not exactly the case for Storm Tracer. They kind of bend that rule a little bit. Storm Tracers are more forgiving. Because motors assist the movement, you can run softer compounds than normal skates. And some electric platforms already do. Electric skateboards often use car-like compounds for their wheels. Especially when you talk about mountain boards, they usually use not only car-like tires, but they even have air tube inside of it. So they're hollow and you have to measure the pressure and everything. Thundrblade itself is running a very soft threaded rubber wheel, like you can see here. They're specially tuned for off-road and mixed terrain. So since we have this really grippy wheel right here, how do we actually turn? So the compromise here is using a rubber wheel on the back and a normal line skate wheel on the front. So we have normal grip on the front, which is the wheel that actually turns, and a lot of grip here to brake and to accelerate hard. But they also increase rolling resistance. I have less range because of that. You gain traction, braking, confidence, and versatility of terrain, because I can go over slightly less than ideal for skating terrains. But since you pay for it in efficiency, nothing's free, again, trade-offs. So let's step back for a second. In this arc, we talked about three things, but really it's just one conversation. Suspension decides how you survive impact. Wheel diameter decides how you manage energy. Grip decides how much control the streets give you. None of these exist alone. You change one and everything else feels different. That's why setups often feel wrong, even though they are quite similar. So the real question here is not what's right or what's wrong. It's about what kind of rider you are. Do you want speed and efficiency? light, agile movement, maximum grip and terrain confidence, or you're gonna try and make a do-it-all balanced setup. Every storm tracer reflects its rider. And that's what tracing the build is all about. We're not chasing numbers, we are understanding the topics. What choices do we have and how they impact the ride feel? We are defining behavior, we are defining feel, we are defining the culture. And we stormed the streets today. Until next time, trace the storm. Tracers out.